Welcome back, everybody. This is our second class or session in NEET previous year questions for chapter Electromagnetic Waves of class 12th. Before this, we have made one video in this series, and other videos are also available for the previous chapters. And all of those videos can be found on our YouTube channel's playlist section regarding NEET and JE also. Now, if you find these videos helpful or useful, then do like the video, subscribe to channel, and if you want to support us financially, then you can scan any of these QR codes in front of your screen, and with whatever amount you may want to, any amount will be quite appreciated. So, with this, let's start today's video. In the previous one, we covered up to I think question number 15 or something. This was the last question which we covered. Now today let's start with the next one. So here, which of the following statement is false for the properties of a electromagnetic waves? Both electric and magnetic field attain maxima and minima at the same place in the same time. So if we represent electric fields and suppose this is we can say suppose this is magnetic component, then electric component can be represented like this, and they have a property that their maxima and minima are the same time. Means suppose this is the time for the electric field maxima, then this again is the same time for the magnetic field maxima. So we can say statement A is right here. The energy of the electromagnetic waves is divided equally. So yes, it is equally in both electric and magnetic components, and both electric and magnetic field vectors are parallel to each other. So that is wrong here, because electric vector is perpendicular to the magnetic vector in case of EM waves. So option C is wrong here, and these waves do not require any material medium for propagation. So yes, they can even travel in vacuum, and they have the highest speed in vacuum. So option D is right, and we have to find the false statement. So option C is the false statement here, and that will be the right answer for this question. Let's move to the next one. The electric field part of an EM wave in a medium represented by Ex is equal to 0. We have Y component and Z component. So we have to find out direction of motion and wavelength and frequency. So a generic equation will be given like this: E naught times sine. Oh, so here we have cos. So we will take cos of omega t minus of k times x. So now comparing, we will get omega is equal to 2 pi into 10 raised to power 6, and k is equal to pi into 10 raised to power minus 2, and k is negative here. Now velocity will be minus of omega by k, so that will give us 2 pi into 10 raised to power 6 divided by pi into 10 raised to power minus 2. So pi get cancelled, and we have 2 into 10 raised to power 8 meter per second. That's the velocity. And direction will be, as this is wave is in x, so here due to negative sign this velocity is positive, so direction will be in the positive x direction. So we can say here moving along x, moving along x. So option D is cancelled because here we are moving along minus x, and option A is also cancelled. Now coming to the frequency. So frequency can be inferred from this relation, that omega is equal to 2 pi times frequency, and omega is here 2 pi into 10 raised to power 6 should be equal to 2 pi times frequency. So 2 pi get cancelled, and frequency is 10 raised to power 6 hertz. So frequency is equal in both of the options, and now we have to find wavelength. That can be inferred from the velocity and frequency relation. We know velocity is frequency times lambda, so that is 2 into 10 raised to power 8 is equal to 10 raised to power 6 times lambda. So from this, lambda comes out to be 200 meter. That is option C. So option C is the right answer here. Let's move to next one. The velocity of electromagnetic radiation in medium of permittivity epsilon node and permeability mu node is given by. So in free space, velocity or speed of light is equal to under root 1 by mu node times epsilon node. That is option C here. In the next one, the electric and magnetic field of electromagnetic waves are. So option A, they are opposite phase perpendicular to each other, in opposite phase parallel to each other, in phase perpendicular to each other. That is the option C. Magnetic and electric field both are in phase and perpendicular to each other. So option C is the right answer here. Now in the next one, velocity of EM waves is parallel. So we know that velocity vector for EM wave is equal to E cross B. So here velocity will be parallel to E cross B, or we can say option B. Now in the next one, the wavelength of frequency is 100 hertz is. So okay, we have frequency given and we have to find wavelength. So assuming this wave is traveling in vacuum, so we can write that speed of light, that is 3 into 10 raised to power 8, should be equal to lambda times frequency, that is 100 here. So lambda will be 3 into 10 raised to power 6 meter. That is option B. So option B is the right answer here. In the next one, the frequency of EM wave, which is best suited to observe a particle of radius, is of the order. Now, to observe a particle, the size, or we can say object of size, or size of object must be comparable to the lambda used. And for the edge case, we can say that size of object should be equal to at least twice of the lambda, or oh sorry, not twice, half of the lambda use. So we are using a edge case. So lambda by 2 should be equal to the size of the object, and we have radius of the object is equal to this value. So size of the object will be approximately its diameter, so that will be lambda by 2 should be equal to twice. Sorry, correction here. Previously it was right that for the edge case, but we will take for the good approximation that size of object is twice of the lambda. So now twice of lambda is equal to size. Now size is equal to diameter. So twice into 3 into 10 raised to power minus 4, it is in centimeters. So into 10 raised to power minus 2, it is in meters now. So lambda will be 3 into 10 raised to power minus 6 meter. Now we can calculate the frequency. That frequency will be C, that is 3 into 10 raised to power 8 divided by lambda, that is 3 into 10 to the power minus 6. So this will give us 10 raised to power 14 hertz. That is option B for us. So normally what we have, that size of object should be comparable to lambda use. For better resolution, we take twice lambda. Now let's move to the next one, the electromagnetic radiation which has the smallest wavelength. So for lambda to be the smallest, frequency has to be the highest, and for a wave that has a highest frequency means its energy is also highest. Now we know that for the between X and gamma radiation has the highest gamma radiation has the highest energy, because these radiations are produced in the nuclear transition, whereas X-ray are produced during the electronic transition. So option B will be the right answer here. For the next one, the electromagnetic wave have the shortest wavelength here. So in these cases, shortest wavelength, again lambda is shortest, means frequency will be the highest, and if frequency is highest means energy is highest, and that is again for the same, that gamma rays has the highest energy. Now that's the next question. The minimum wavelength of X-ray produced by an electron accelerated through a potential difference of V volts is proportional to. So when we accelerate an electron with the help of some potential, then it will acquire energy that will be equal to E times the potential, or charge times the potential. And when this electron hits some target, then it will lose all of this energy in the form of radiation, so it will be H times the frequency. So here from this we can write that EV is equal to, frequency is C times lambda, and from this we can write that lambda is inversely proportional to V, where V, capital V, is the potential. So option D is right here. In the next one, we have to find out, we have to match list 1 with the list 2, where we have radiations and wavelength. So we know that X-rays are given here, and for X-rays we know that energy is highest, so frequency is highest, which means lambda will be the smallest, and smallest value of lambda is 10 raised to power minus 10 meter here. So we can say D should match with the 1, and if we see from that, option B get cancelled, because in all three options D is matched with 1. Now coming to the AM radio waves. So radio waves going to have the highest value of wavelength. So the largest value available is 10 raised to power 2 meter. So AM wave should match with the 2. So A should match with the 2, and that is only possible with option D. So option D is the right answer here. Let's move to the next one. Which color of these has the longest wavelength? So we know for lambda to be the largest, frequency has to be the smallest, and it means energy has to be the smallest. So the color will have the largest wavelength, that will be near infrared region, and near infrared we have red color. So option D is the right answer for this question. In the next one, the energy of EM waves is the order of 15 kilo electron volt. To which part of the spectrum does it belongs? So here energy will be 15 into 10 raised to power 3 electron volt. So from this we know that lambda can be found out using Hc by E, and Hc is 1240 electron volt nanometer divided by E, that is 15 into 10 raised to power 3. Solving this we will get 0.83 angstrom, and this is in X-ray region. So option A will be the right answer for this question. In the next one, the condition under which microwave oven heats up a food item containing water molecule most efficiently is. So option A, the frequency of microwave must match with the resonant frequency of water molecule. The frequency of microwave has no relation with the natural frequency of water molecule. Microwaves are heat waves, so always produce heating. Infrared wave producing heating in the microwave oven. So here only possible option, that is option A, because when the microwave frequency is equal to frequency of vibration of water molecules, then this is a condition of resonance. And we know that at resonance maximum energy is transferred from the one medium to another. So that's how microwave transfers their energy to the water molecules. So option A is the right answer here. In the next one, the decreasing order of wavelength of infrared, micro, ultraviolet and gamma. So we have to find decreasing order. So in decreasing order, gamma will be the last one. So we can say option A and B is cancelled. And we also know that infrared has a, we can say higher wavelength or lower energy as compared to the UV. So infrared will come first, and then we will get ultraviolet, and microwaves are also lie in the lower infrared. So option D will be the right answer for this question. In the next one, if lambda V, lambda X and lambda M represent visible, X-ray and microwave respectively, so we know that for the X-ray, wavelength will be the shortest, and that is represented by lambda X. So lambda X will be the smallest. So option A and C are cancelled here. And for the we know microwaves lies in the lower infrared, so their wavelength will be higher or larger as compared to the visible region. So we can say micro lambda m will be great should be greater than the lambda visible, and that will be greater than the lambda x. So here we have option B. So option B is the right one. Now moving ahead, we consider that the radiation emitted by the human body, which of the following statement is true? The radiation emitted is in the infrared region. The radiation emitted only during to the day, that is wrong here. So as body emits radiation in both day and night. Radiation are emitted during the summers and absorbed during the winters, that is also wrong. And radiation emitted lies in the UV region, so that is also wrong. Only option A is correct here, and that's why some military application uses infrared cameras to find out the humans or to catch the human. Even and with the help of infrared cameras, humans can be sensed even on the other side of the wall, because infrared radiations can penetrate walls. Moving ahead, which of the following rays are not EM rays? So heat rays are EM rays, gamma rays are also EM rays, X rays are also EM rays, beta rays. These are not EM rays, these are basically alpha particles. Oh, sorry, not alpha particle, these are electrons, and these are particles. So these are not EM rays. Yeah, although if these electrons are getting accelerated, so they will emit EM rays, but they are not itself EM waves or EM rays. Now, which is having the minimum wavelength? So minimum wavelength will be the gamma rays, because they have the highest energy. Now, which of the following causes greenhouse effect? Greenhouse effect is caused due to the infrared rays. So that is option A. The frequency of gamma, X-ray and UV are ABC respectively. So we know that gamma ray is highest energy, so their frequency will be the highest. So A will be highest, then X-ray comes and then UV. So option A will be the right answer here. Ozone layer blocks the radiation of wavelength. So we have to find out that which radiation ozone layer blocks. So we know that ozone blocks UV radiations, and UV rays has wavelength around 300 angstrom, and that will be equal to 3 into, oh sorry, 3000 angstrom, that will be 3 into 10 raised to the power minus 7 meter. Now as we move upper or ahead in the UV region, so wavelength will reduce, energy will increase and wavelength will reduce. So it will block all the wavelength all the radiations which have wavelength smaller than 3 into 10 to the power minus 7. So that is option A here. Now moving to the next one. The structure of solid is investigated using X-ray, and for that we study Bragg's laws of X-ray radiation, where we have n lambda is equal to 2d sine theta for the X-ray diffraction. Now in the next one, which of the following is the longest wave? So longest wave means lambda is highest, and if lambda is highest means energy will be the smallest, and that is radio waves. So option D is the right answer. So this covers our this chapter, and hopefully you liked it. If you have still any doubts, you can put them in the comment section. I will try to resolve them. And if you like these videos, then you can scan any of these QR codes and donate us with whatever amount you want. And with this, we will meet in next video.